Okay, so sometimes we need to find proportional constants using graphs. We have to be able to find them in contexts, in equations, and tables, but we also need to be able to find them in graphs. So this is the video about finding them in graphs. The proportional constant, again, is that numerical value that tells you how one quantity is changing to another. So here I've got two quantities. I've got squares and I've got triangles. How are triangles changing depending on the number of squares that I've got? Well, based on the graph that I see here, the first thing we can do is we can try to find the y value when x equals 1. And this is the exact same thing you do on a table. Try to find the y value when x is 1. So here I'm going to find where 1 is on the x-axis. I'm going to go up until I hit a line, and at this point it turns out that that y value right there at that line is a 3. So this y value right here, this 3, is my proportional constant. So I could write that the proportional constant, or PC as I've been abbreviating it, equals 3. That's how I can find it in the table. Okay, find the y value when x is 1 by looking at the graph. The second way is also just like a table. Find the change in y for every single x increase by 1. So first I have to notice that my vertical lines are going by 1s. 0 to 1 to 2 to 3. Every line represents a 1 whole increase in my x unit of squares. So what can I do? Well, I could sort of start going over my 1 unit and then count how many up I've got. And when I do that, I'm going by 3. So when I go 1 unit over, not just one line, but 1 unit, 1 to 2, I count how many up I'm going. And in this case, I'm going up 3. Go over 1, I'm counting how many up that I'm changing, and I changed by 3. Went over 1, count up how many I'm changing, and I went up 3. Go over 1, count up how many I'm changing, and I went up by 3. In every single case, I was increasing by 3 on my y-axis for every single 1 change that I went over. Over 1, I went up 3. Over 1 on the x, went up 3. And again, I'm not carrying that I'm going over 1 line, I'm carrying that I'm going over 1 whole unit. 1 vertical line is a 1 whole unit change on the x. So that's another way I could find it. It's my change in y for every x increase by 1, just like on a table. If even that's not clear, I can resort back to my proportional constant is the ratio of y to x. So triangles divided by the number of squares. So I could find any points that I've got. In this case, this point tells me that I've got a value of, that's the point 2 comma 6. So I'm going to do this. I can find the point, I can find its coordinates. In this case, I've got 2 comma 6. And so what I can do then is y of 6 divided by my x of 2, and I can find the proportional constant that way, a 3. Now that seems like unnecessary work in this particular graph, because it's easy to see that when x is 1, I've got a 3. But what if we look in situations like this, which you will have to do? When I do the first trick, I'm not sure where the x is stopping. It's clearly between 1 and 2, but is it 1.25? Is it 1.5? Is it 1 3/3? Or excuse me, 1 1/3? It is unclear, so that first strategy doesn't work here. The second strategy doesn't work, because if I'm not sure where this ends, I can go over 1, but I'm not sure how much that goes up. Is it going up 1? Is it going up 1.5? Is it going up 1 3/4? It becomes unclear. So in this case, the best strategy is to use, find a clear point, a clear intersection that has, where you can find a point. So find a clear intersection. And in this case, it looks like our clearest intersection is going to be right here at 3 for your x. It seems to make a clear intersection right there. So we've got an intersection of the point 3 comma 4, And what we're going to do is use that point right there and this strategy. Find the ratio of y to x. So in this case, we had a y value of 4. So we're going to divide by its corresponding x, which was the 3. When x was a 3, when you had 3 squares, you ended up having 4 triangles. And so in this case, it turns out that our proportional constant is 1 1/3, or you could, some students leave it as the improper of 4/3, or you could approximate it as the decimal of 1.6, or maybe if you round it a little bit more accurately, 1.67. These would be 3 ways to represent, in this case, the proportional constant, and we found it by doing y divided by x. We look for a clear intersection and do y divided by x. In fact, here's another intersection right here where we are passing through 6 and our y value is an 8. So we could use this point as well. And if we did, we'd have our y value of 8. That's a messed up 8. Our y value of 8 divided by 6, which will also result in 1 1/3 or 4/3. So that's another way to find it in a graph.